Alright, hey there. I am making this video for a few of you that have been out lately due to sickness. Hope y'all get to be feeling better. And hopefully these videos will help get you caught up and not feel so stressed out. Now I will kind of inform you that we are underneath a tornado watch right now, so those chimes that you hear in the background are my wind chimes that are just blowing like crazy. I really don't think there's going to be a tornado because the sun is shining. But, you know, that's how it is around here in Tennessee. Anyway, so let's move on. Today's lesson is about simplifying rational expressions, and you will get some notes on this once you return. Let's take a look at what the definition of a rational expression is. And basically it's just, let's go back. It's really nothing more than a fraction in which the numerator and the denominator are polynomials. So you just have a fraction that's algebraic. And when we simplify a rational expression, it's the same as what we would do when we reduced fractions in the 4th or 5th grade. We're just taking it down to lowest terms. So with that in mind, let me forewarn you of the undefined fraction. Because we have fractions and they are algebraic, which means there's going to be variables in the denominator, we need to watch out for this guy right here. And we have talked about the undefined fraction in the past, especially when we were referring to asymptotes with exponential and logarithmic functions. But let me just remind you that this is not a number. It presents itself as a number, but it's not. Because you can't have part of nothing. So for example, I tell the class, hey, you want some pizza? And everybody says yes, and I don't have any pizza. So how can you get a piece of pizza that doesn't exist? So that's kind of in the same framework here. You cannot have part of nothing. So another thing is, because it appears in the denominator at times, we have to scout it out. We have to identify it. And we have to be able to say, you're not invited. You're excluded from this particular fraction. So it scoots in with the domain, which is your x values. And again, you have to kind of play detective, and you have to scout it out and identify it and say, you are not invited to this particular function. All right, so we'll practice that as well as we go along. So hopefully that explanation about the undefined fraction was clear enough. So we call these undefined fractions restrictions. We can call them excluded values. Those are some other names that we might be giving it. Of course, this is a little meme that has come along. So let's take a look at an example. Here we have a rational function. In other words, we have a fraction. And we have x's in the denominator. And we want to make sure that we don't wind up with anything over 0. So we're going to try to find the value of x that would give us that undefined fraction. And that number is going to be the number 7. Now some of you might be saying, what about -1? Well, again, let's go back to the pizza analogy. If I brought in a pizza and it existed, it's very possible that you might not get any of it, especially if you're absent. You'll get 0 parts of that pizza. So it's possible. 0 is a number. So we don't want to mess with the numerator. We're just kind of looking for the undefined values in this denominator. So that's it. We're done. Let's look at another example. In this example, it might be in your best interest to factor this denominator. You don't have to, but we tend to lose an answer when we don't factor it. And we know this is the difference between two perfect squares, which is going to be x plus 3, x minus 3. And so the two excluded values are 3 and -3. Okay, so here's some more examples take a look at them for a second. All right, all of them referring to the denominator. This one right here, set it equal to 0, pull the 1 over to the right hand side, divide by 2, that's where you get the 1/2. Okay, so I might end this video here for right now because it's been 5 minutes and I'm sure some of you just want to take this in small portions. So we'll come back and we'll look at how to simplify rational expressions.